All right, welcome back. Today, we are diving headfirst into something, well, truly radical. It's a hypothesis that doesn't just want to tweak our understanding of physics, it's trying to rewrite the entire rulebook for reality itself.
So let's kick this off with a question that, has probably bugged anyone who's ever really thought about the universe. For all our incredible science, why do our two best theories, the ones that are proven right again and again, why do they seem to completely hate each other?
Okay, so the whole problem really boils down to this. On one hand, you've got Einstein's general relativity. It's just brilliant for describing the big stuff, right? The cosmic dance of planets, stars, and galaxies. Then, on the other hand, you have quantum mechanics, which is absolutely incredible for the super tiny world of atoms and particles. The problem? They don't play nice. They describe two totally different realities that just cannot be reconciled.
And what's really fascinating is how we've tried to fix this. To sort of glue these two theories together, we've had to invent these mysterious placeholders. You've heard of them, dark matter and dark energy. We're told they make up a staggering 95% of everything. But, and this is the crazy part, we have never ever actually found any of it. Not a single trace. So, that leaves us with this picture of the universe that's kind of held together with duct tape and hope, full of patches and paradoxes. And that is the perfect stage for the idea we're exploring today, the time force hypothesis, or TFH for short. Basically walks in, looks at the mess, and asks, hey, what if there's a single, way more intuitive idea that just makes all this confusion go away?
The absolute core of this whole thing is, it's a huge shift in perspective. It asks us to forget about separate little particles and all these different forces for a second. Instead, just imagine that the entire universe, and I mean everything, you, me, the stars, the most distant galaxies, it's all just part of one single interconnected ocean of energy. And this ocean is always flowing, always moving, always trying to find a state of balance.
So what does that look like in practice? Well, for starters, you can kind of toss out the idea of a violent Big Bang. Instead of some massive explosion, picture this. Seriously, try to visualize it. You take a single, super concentrated drop of ink and you just gently place it into a huge glass of perfectly still water. What happens? It doesn't explode, right? No, it just diffuses. It spreads out, creating these beautiful, complex patterns as it tries to balance itself out. And that, according to TFH, is a much better model for how everything got started. Okay, so let's take this flowing ocean of energy idea and see what happens when we apply it to two of the biggest concepts in all of physics, time and gravity. And believe me, this is where things get really wild. We all experience time as this constant river, right? Always flowing forward, one direction only. But what if that's not real? According to TFH, that entire feeling is an illusion.
So the theory says you're not actually feeling time pass. What you're feeling is just change. You're feeling the universe's energy shifting from one state to another. It's like watching those snapshots of the ink spreading in the water. The tick-tock of the clock is just the universe going from snapshot A to snapshot B. And the implication there is just mind-blowing. If all that energy ever reached a perfect, total balance, time itself would just stop.
All right, what about gravity then? I mean, we all learned in school that big things pull on smaller things. And then Einstein came along with this absolutely beautiful idea that massive objects are actually warping spacetime, and we're just rolling down those curves. That's our modern view of gravity. Well, the time force hypothesis looks at that and just flips the whole thing completely upside down. It asks, what if gravity isn't a pull at all? What if it's actually a push?
To get your head around this, the theory has a fantastic analogy. Picture a bathtub drain. Now put a little rubber ducky in the water nearby. Is the drain pulling the duck towards it? Not really, right? The duck is being pushed by the current of water that's flowing towards the drain. TFH says that's gravity. You're not being pulled down to Earth. You're being pushed down by a cosmic river of energy that's flowing into this really dense spot we call Earth.
Okay, so if gravity is just this energy flow, then what about, matter itself? Right now, physics says particles have a property called mass. TFH says, nope, you got it backward. Particles are their mass. They're just these tiny, stable little whirlpools of swirling energy. So mass isn't something a particle possesses, it's just a description of how much that little whirlpool resists moving through the bigger ocean of energy. A particle with a lot of mass is just a really sticky vortex. It's harder to push around.
All right, so here's the big payoff. Let's see how this one simple idea claims to solve some of the biggest mysteries in the entire universe. First up, dark matter. For decades, we've been hunting for this invisible stuff because galaxies are spinning so fast they should be flying apart. But what if there's nothing to find? TFH suggests a galaxy is just a gigantic slow-motion whirlpool of energy, and the stars on the outer edge, they're not being held in by some invisible matter. They're just caught in the fastest part of the current, kind of like the edge of a spinning record. And just like that, you don't need dark matter anymore.
And what about black holes? You know, the scariest things in the cosmos. General relativity says that at their core is a singularity, a point of zero size and infinite density. Now, whenever you hear the word infinity in physics, it's usually a huge red flag that your theory has just, broken down. TFH says, forget the infinity. A black hole isn't a point of infinite collapse. It's just the universe's most perfect, most stable energy vortex. It has a maximum but totally finite energy density. And poof, the singularity problem just vanishes. No more broken physics.
But look, this isn't just about clever analogies with bathtubs and ink drops. The hypothesis proposes that all of these things we've talked about, from time itself to the spin of a galaxy, can all be described by one single fundamental mathematical rule. And there it is, the mathematical heart of the whole theory, the TFH master equation. Now, I know it looks a little intimidating, so don't worry about all the symbols. Because while the math is complex, the idea behind it is stunningly simple. This one single rule is proposed to govern the behavior of that entire cosmic ocean of energy we've been talking about, the whole shebang.
So let's just quickly break it down into plain English. That first symbol, phi, that's just the ocean of energy itself. Easy enough. The real magic happens in the other two parts. Think of alpha as a kind of cosmic friction. It's what makes things slow down and spread out, creating what we feel as the arrow of time. Then you have beta. Think of that as a structure term, like a cosmic surface tension that lets the energy clump together and form those stable whirlpools. You know, the things we call particles.
Okay, but here's the most important part. Is this just a cool story or is it actual science? Well, to be science, it has to make predictions we can test, and it does. It makes very specific, falsifiable predictions. It says the universe's expansion should be slowing down in a very particular way. It says gravitational waves should have certain echoes or damping effects, and these are things we can actually go out and look for with our best instruments, like the James Webb Space Telescope and LIGO.
You know, if this hypothesis is even remotely on the right track, it changes everything. For centuries, we've kind of viewed the universe as this giant, cold clockwork machine, right? With all these separate gears and forces. This is a totally different picture. It paints the universe as something more like a single flowing, almost living system, a vast ocean where every single part is fundamentally connected to everything else.
So what do we take away from all this? I think I'll just leave you with this thought from the theory's authors. Entropy is a wave's whisper across boundaries. As energy flows seek balance, horizons birth time. Let's test these whispers. Look, this is obviously a huge, ambitious idea, and it's meant to be challenged and tested. To help with exactly that, the creators have actually put an AI co-author of the theory on their website, which is pretty cool. You can go and ask it questions directly. I definitely recommend checking that out. Thanks for going down this rabbit hole with me today.